Hello everyone, welcome to my GenChem talk. So today we actually will talk about some common chemicals used every day, and I will talk about the common name and the official name and the structures. First is most common chemical. You probably didn't realize it's actually a chemical, right? So water, the formula is actually H2O. 2 is the subscript. That means there are 2 hydrogen atoms and 1 oxygen atom in 1 molecule of water. Officially, it's called dihydrogen monoxide. Another common chemical used in kitchen is table salt. This is the formula: 1 sodium, 1 chlorine, but the name is called sodium chloride, not sodium chlorine. Okay, sodium chloride. The third chemical we talk about here is baking soda. Baking soda is a common name. The formula of the baking soda is 1 sodium, 1 hydrogen, 1 carbon, and 3 oxygen. And officially it's called sodium bicarbonate. It also called sodium hydrogen carbonate. That's also the official name. And this is also widely used in the kitchen. Another common chemical used is muriatic acid. The formula is 1 hydrogen, 1 chlorine. It's called hydrochloric acid. It's a strong acid, and you can use this to adjust the pH of your swimming pool, and this is also the acid in your stomach. Quartz, it's a common name of this silicon dioxide. Officially, it's called silicon dioxide. The formula is 1 silicon, 2 oxygen here. And it's beautiful crystal. Another beautiful crystal is diamond. But the diamond actually is just a pure element of carbon. And it's also called an allotrope of carbon because allotrope means the special physical form of the element. There are other allotropes of carbon like graphite, graphene, and they are all pure carbon element. But they have different structure. And the carbon, if they form the tetrahedral structure network, that will be the diamond. Very, very hard, the hardest material. Another chemical is dry ice. We used a lot. The formula is carbon, 1 carbon, 2 oxygen. Officially, it's called carbon dioxide. It's called a dry ice because this it's a solid form of carbon dioxide. At the room temperature, normally the carbon dioxide is a gas in the air, but the solid state of the carbon dioxide is very, very cold. It's negative 109 degree Fahrenheit. It's about negative 78 degrees Celsius. So it's very, very cold. But it's dry because it will not melt. It will actually directly sublime. That means it will directly evaporate to gas from solid state to gas state. So it's clean. Laughing gas is another common chemical used in hospital as anesthesia, and the formula is N2O, so 2 nitrogen and 1 oxygen atom in 1 molecule of this laughing gas. Officially, it's called dinitrogen monoxide. Dinitrogen monoxide. It's also another common name is called nitrous oxide. Natural gas, CH4. Officially, it's called methane. I have to clarify that natural gas actually is a mixture of methane, ethane, propane, butane, but methane is a major component of natural gas. It's important fuel. Okay. Last common the salt today we'll talk about is Epsom salt. Epsom salt, the formula is magnesium, sulfur, and oxygen, 4 oxygen atoms. And Officially, it's called the magnesium sulfate. The SO4 is sulfate. Actually, it's a 2 negative charged polyatomic anion. It's kind of like a type of traditional medicine, so it can be used to relax your muscles, okay, and it's all kind of the painkillers. Okay, so this is those simple chemicals used. Now let's talk about a little more complicated ones. So for example, okay, table sugar. It's a little bit more complicated structure here. Table sugar's official name is called sucrose. The formula includes 12 carbons, 22 hydrogens, and 11 oxygen atoms. And the structure of this table sugar shown here. And you can see the left part of this table sugar is actually a glucose, and this is 6-member ring, and the right part of this sucrose is actually fructose. So glucose and the fructose, they are so-called monosaccharide. So they are the simplest unit of the sugar. And table sugar, the sucrose actually is called a disaccharide because they are 2 monosaccharides. And you can also see a lot of hydroxyl group here. So this hydroxyl group will form hydrogen bond with water. So that's why sucrose has a good solubility in water. Okay, this is the table sugar. Vitamin C. Vitamin C, the other name is called ascorbic acid. So this also implies that this is acidic. The formula include 6 carbons, 8 hydrogens, and 6 oxygens in 1 molecule of this vitamin C. And the structure shown here, you can see it actually has a cyclic structure as a core, and this part is called ester, but when it's cyclic, it's called lactone. And this is a double bond here, and you can also see a lot of hydroxyl group here. So that's why this is also soluble in water. And this proton, the hydrogen, we call the proton for acid, it's the most acidic proton in the ascorbic acid, okay, in the vitamin C. It's very important for our nutrients every day. We need to take vitamin C. Okay, let's talk about caffeine. Caffeine is actually officially is called 137-trimethylpurine 2,6-dione. Molecular formula include 8 carbons, 10 hydrogens, 4 nitrogens, 2 oxygens. Let's look at the structure of caffeine, and you can see it's actually fused bicyclic core structure. Actually, this structure is called a purine. Actually, of course, you have the carbonyl here, okay, methyl there, but this is the purine. Actually, is important structure. This type of structure is found in a lot of biological active compounds, such as base pair of the DNA. Okay, so this is caffeine. Next is camphor. Camphor is a traditional medicine, actually, similar with Epsom salt. Camphor used to relax muscle, and also it's kind of like a painkiller used in history. The formula of the camphor is 10 carbons, 16 hydrogens, and 1 oxygen in 1 formula. The structure is shown here, and this is called a bridged bicyclic compound. This part is carbonyl. So when you have carbonyl here, this is actually a ketone also. So this is also important in history. I think people are still using this camphor. Next one is cholesterol. So this is a famous molecule, and our body can synthesize cholesterol every day. Actually, it's also very important, although you don't want too much in your body, but it's important. The molecular formula includes 27 carbons and 46 hydrogens and 1 oxygen. You can see this is a big molecule. And look at the structure. Yeah, it is big. And This is a typical, if you see this is 6-6-6-5 fused member, this is called a steroid, okay? And that's why the cholesterol belongs to steroid or sterol. And you can see a double bond here, it's unsaturated, and this is alcohol, hydroxyl group. So that's why it's called cholesterol. OL means alcohol, okay? The cholesterol, it is important for our body. I said again, right? You just don't want too much. Okay, is aspirin. Aspirin is a very common medicine. The other name for aspirin is called acetylsalicylic acid. And again, this is acidic. You can see it's acid. Molecular formula, 9 carbons, 8 hydrogens, 4 oxygens. The structure of aspirin shown here, and actually this is carboxylic acid here, this part, and with benzene is called a benzoic acid, and this part is an ester, it's a methyl ester here. So this is the acidic medicine. Tylenol is another common medicine. Okay, so the other name for Tylenol is acetaminophen, and the molecular formula is 8 carbons and 9 hydrogens and 1 nitrogen, 2 oxygen. Structure of Tylenol shown here. So you can see this is acid, but with the nitrogen, it's carbamic acid actually it's called. And but this, look at this part, is actually phenol. Okay, so benzene with a hydroxyl group, it's called phenol. And so this is another very common medicine. A similar one, the ibuprofen, did the same thing. It's a painkiller and fever relief. And molecular formula is 13 carbon, 18 hydrogens, and 2 oxygens. Structure, it's very similar. You can see the core is also a benzene ring, and you have a normal carboxylic acid here, and other alkyl group here. This is an isobutyl group. Okay, and you may notice that most of this common medicine has a benzene ring, and ironically, benzene itself is the pure benzene itself is toxic, but when the benzene has other substitution on the benzene, actually that's a structure of a lot of medicine. Okay, so that's the introduction of those common chemicals in our everyday life. If you have any questions, let me know. Okay.